math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. So let me go ahead and begin the recording. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. Without further ado, I will hand it over to our presenters, and I will also be posting the link to the Math 1324 room in the everyone chat.
So good afternoon, welcome everyone. So happy that you're able to join us. Again, my name is Ruben Carizales and I will be starting today's presentation. But before I get started, I'm going to give a few seconds for all of you students who are reviewing for your Math 1324. Again, the link you'll find in the chat room. So I'll give a few minutes for those of you who need to go to that chat room to go ahead and click on that link. Okay, very well. For those who are staying behind, we are in this chat room, we're going to be covering the Math 1314. So for today's presentation, we're going to cover how to evaluate combinations of functions and composite functions. Okay, so before we get started with the fun stuff, let's just review some of the things that again, because this is a summer class, for sure all of you all covered this, but let's review some of this. So function notation, we are taking an equation that has the variable x and y, and the y is being replaced by f parentheses x parentheses. So we just simply call this f of x, okay? So our previous equations that you've seen in chapter 1 were given in this form: y is equal to x squared minus 2. To convert this into function notation, we're going to express it as f of x is equal to x squared minus 2. Again, the y is being replaced by this name, f of x, okay? All right, so how do we evaluate functions? So again, when we are looking to evaluate the function for x equals -2, all we have to do is everywhere we see an x variable, we're going to plug in this value -2, okay? So you can think of this as a generating machine, okay? We're going to put in a value and the answer is our output. So that's another way to look at functions. So functions have an input value and it's going to produce an output, okay? It's our answer. All right, so when we put in our input, x equals -2, into our equation, again, everywhere we see x, we're going to replace it with this -2 value. And because this value is getting squared, I want to put parentheses. That parentheses means that I am squaring this value, -2, and it's not just 2, it's -2. I have to put in that sign. So when I do that, okay, I'm going to evaluate -2 squared, which is going to give me a 4. And then I finish the math operation. It asked me to subtract this input that I had just plugged in, that I got a 4, subtracted by 2. So 4 minus 2 is going to give me an output of 2. Okay? So again, my input was a -2, and my output, my result, was a +2. And to represent this input and output as an answer, we always are going to combine it as an ordered pair. And we call it ordered pair because we always put the x value first and then the y value. So our ordered pair of this function is -2, 2. Okay? All right. So let's go ahead and consider this function. F of x is equal to x squared minus 2. So what does f to the input -3 mean? Okay, so I'll give you a few seconds just for you to write it out yourself on paper, and we'll review it together. Okay? All right, so again, what we are going to do is everywhere we see x, we're going to plug in this input value, this -3. And again, because it's a negative value, I'm going to encapsulate it in parentheses. So -3 squared plus 2 is my evaluation. Okay, so when I do -3 squared, that's going to give me a +9, and 9 plus 2, my result is going to be 11. And so my ordered pair is parentheses -3, comma 11. I know all of you got these answers, right? I'm positive. Okay? So if we were to graph this, um, again, you plot it in as the ordered pair. So let's look at some more examples. Let's give this, given this function, the square root of 3x minus 2. And we're going to do several of them, okay? So let's do one at a time. A is going to be x equals 2. So again, if I'm evaluating this function, I'm going to, everywhere that I see x, I am going to plug in this value 2 as my input. So 3 times 2 is going to give me 6. So 6 minus 2 is going to give me 4. And the square root of 4 is going to be 2. Okay? So my input value was 2. My output value on this was also 2. Okay? All right, let's look at B, the same thing. Okay? Everywhere I see x, I'm going to plug in the value a. Okay, so we have 3 times a minus 2. So we're going to just simplify this. Just 3 times a is just 3a minus 2. Okay, and when you're putting these answers on your computer, this is exactly how the computer wants it. You know, just the square root of 3a minus 2. I cannot simplify it. A is just another variable, so I just leave it alone. Okay, so let's do the C one, the one that's a little bit more challenging. Okay, so C had two terms, right, to plug in into our function. So again, everywhere I see x, I'm going to plug in 6 plus h. Okay, in order to evaluate this, I'm going to distribute. Okay, I'm going to distribute this 3 into the 6 plus h. Yes. Okay, so when I do this, 3 times 6 is 18. 3 times h is 3h, and then I have that minus 2. I have two like terms. I have an constants. I have an 18 and I have a -2, and I can combine this two. So 18 minus 2 is 16 plus 3h. And again, I can no longer simplify it, so I'm going to leave my answer as is. So when my input was 6 plus h, the answer, the output, is just going to be the square root of 16 plus 3h. Okay. Any questions so far on evaluating functions? Great, awesome. So let's move on forward. Oh, did someone have a, Gian, did you have a question? I saw that your hand was. I'm sorry, go ahead.
How do you write that in ordered pairs?
Okay, so if I go back, thank you for asking. Okay, so if I were to if I were to ask, okay, on these problems, because I'm just evaluating, I wanted you to give you the answer. So since for instance on this first one, on the A, since my input was 2 and my output was 2, I am actually getting two numbers. So for A, as an ordered pair, would be written like this: my input was 2 and my output was 2. And again, there we say that they're ordered pairs because when we write these pairs, we always write the x value first and then our y value. Okay. Now on B and C are a little different, as you can see. These answers, square root of 3a minus 2, what this means is that we generate multiple answers. There's just not one single answer. Now, if I were to write it as an ordered pair, because I could do it, but we normally don't do that because, again, this is not a number. This is just a representation of an infinite number of solutions. But if we were to write it as an ordered pair again, we would do that. Our input was A. That one goes first. Again, this is our input, and it's always represented by our x value. And our output was this, the square root of 3a minus 2. Okay, this would be my ordered pair. Okay, that's my output. So Again, your computer, I don't think will ask you to do something like this a lot, but if they did, this is the representation. This would be the ordered pair. This is my input A, and my output is the square root of 3A minus 2. Same thing with the C, okay? My input was 6 plus H. That is the X value that was going to be evaluated, and my output is going to be the square root of 16 plus 3H, okay? Very great question, awesome. Did this clear it up for you?
Yes, thank you.
Oh, it is my pleasure, okay. All right, any other questions? Awesome, okay, so let's move on. I like this problem because it gives me an opportunity to explain the domain. Domain is very important. Both domain and range are very important in this class, and also on how to write it. The computer, because you're all doing computer work, your computer work will always want you to write the domain and range in interval notation. And to help you with this, let's look at this graph, okay? We have this graph that kind of looks like a W, okay? But I want to point out some very interesting points. If you see here, this graph here starts with an open circle. So when we have an open circle, what that means is that the graph technically starts here. Let's say that this is a value positive 5, but it doesn't exist. It really starts right below 5, okay? Now, if I look at this fill circle, this means that this value does exist, that this graph, it's going all the way up to 5. On this side, it's not going to 5. It's getting close to it, but it never reaches 5. On this one, the point reaches 5, okay? So when I'm looking at this graph, okay, the domain refers to all the x values of the function, all the x values that belong to the function. The range, and let me change my color here, the range refers to, oops, didn't change. The range refers to all the y values that the function can generate, okay? So keep this in mind. Domain refers to your input, aka all your x values. Your range refers to your output, all your y values, okay? All right, so let's look at this. They are asking us to evaluate these input values. And again, when we say input, we're talking about the x value. So here it says, I want to evaluate the function at x equals -1. So if I look at here, I believe here is -1, even though it's not listed. This point here is -1. So what I have to do is I have to go to the graph where this signifies. So if I go here, okay, this here, this point here, which it exists, there's a solid line, this point exists. So the value here at when my x is equal to -1 is going to be -4. I hope you all see it, and I think my answer is on the next, actually, excuse me. I'm still reviewing some of the how to write the domain and range. So I'll get back to it. So let me, since I started and I'm speaking from what the slides have. Okay, so when I am writing my output for this one, my input at -1, my output's going to be -4. That's my answer. Again, this was the x value, and my y value, my output, is going to be -4. Okay, so let me go to the next slide so I can explain a little bit more of this domain and how to write it in as a interval notation. Again, when we're talking about domain, and again, I got ahead of myself, I already talked about all this. Our domain refers to all the x values of the function, and the range refers to all the y values of the function, okay? So here, if I was going to look at my domain for the entire graph, okay, I can see that here, if I look at, this is -1, this is -2, okay? My graph would start here at -2, but as I mentioned to you, this point does not exist. So when we are writing things in interval notation and we say that we are starting at a particular value, but it doesn't exist at that point, we're going to use the notation with the parentheses. The parentheses here is going to tell me that I start at -2, but that value does not exist at that point, means that I have an open circle, okay? And if you see here, this would be one positive one, this would be 2, okay? My graph does end at 2 and I have a fill circle. So the way I'm gonna represent that in interval notation, that point exists, is by a bracket, okay? So whenever we have a parentheses means that we either start or finish at that point, but that point at that value does not exist, meaning that we have an open circle. When we use bracket, we're gonna indicate that the point there stops and it exists, okay? So let's look at our range. Again, our range refers to the y values. So if you see here, my graph starts here, let's say that this is -4 here, and over here is, we can see that it stops at +5. Now, we don't see an open circle here. Even though we have a solid line, that means that this point here exists. There's a solid point on both points here, okay? So this point exists. So if I were to write the range, okay, I'm going to use brackets on both ends, okay? I have a -4, my value exists here at -4, okay? And it stops at 5, even though it stops here, but the graph does go all the way up to the +5. So the range is from -4, it includes -4, so it's a bracket, all the way to 5, which is a bracket. And again, when we're reading interval notation, both for the domain and range, you want to think of like how you read your textbook, okay? We read from left to right, right? So when we're writing in interval notation, we always write the values, our x values, from left to right. Same for the range. Think of your reading like if you were laying down. We're gonna read them from up, down. Another way to think of this or look at this when we're writing in interval notation, you always want to write your answers from smallest to greatest, okay? That's the order that we always want to write things, okay? Especially for interval notation. All right, so let's go ahead and answer these questions that we had before. And again, I answered already the first one because I was getting ahead of myself. So when I have my input value x at -1, I see that my output is a -4, okay? So that is my answer. Let's look at the next one. My input, my x value is 0. So what I want to do is, where in the graph, here is a 0 value, where in the graph does this is represented in my graph? And I can see this is -5, this is -4. My answer would be -3, right? Okay, let's look at the next one. C, my input, my x value is 1. Where does this value correspond to my graph? Oh, okay, so this value corresponds to this -4 value. So my output is -4 given my input. And again, to review ordered pairs, the ordered pairs for answer A would be -1, -4, okay? To the ordered pairs for my answer, this should be B. For my answer for B, my ordered pair would be, my input was 0, my output was -3, okay? For C, my input was 1, and my output was -4. And let's go ahead and do the last one, okay? What is the value when f is equal to 2? So let's say that here is 2. So this, if I go up all the way, it gives me to the value 5, right? So when my input is 2, my output is 5, and if I were to write this as an ordered pair, again, it's always first the x and then the y. So my x value is 2, my y value is 5. Any questions so far? Very good. Okay, let's go ahead and move on. All right, so let's go ahead and evaluate these basic operation functions, okay? So here, when we have this function f of x and g of x, we can also do basic operations to these functions. And when I say basic operation functions, we can always add functions, subtract functions, and multiply functions, and divide functions, okay? So here, this syntax, f plus g of x, that all this means is that we're going to add function f with function g, okay? So when I do this, okay, we're just going to substitute both the function f of x and the function g of x to this operation. Okay, so my function f of x is just 3x minus 7. My function g is 4 minus x. So to simplify again, we are going to combine like terms. So here I have a term that has an x, and I have here a term that has an x, but it has a symbol of a negative in front of it. So we're going to combine these two terms. And then I also have two constants, right? So I have a constant of a -7, and I have a constant of 4. These two get combined. So when I combine my like terms, 3x minus x is going to give me 2x, minus 7 plus 4 is going to give me a -3. Okay, simple as that. Basic function operations. We're going to add or subtract or multiply functions or divide functions. We're just going to replace the values, okay, of those functions. So let's go ahead and do B. Let's do f minus g of x. Okay, so what that means is we're going to subtract function f with function g. Right, so function f is 3x minus 7. Function g is 4 minus x. But I have to be very careful because I am subtracting, and I need to make sure that I need to distribute this negative. So that's why I put parentheses. It's very important that I don't forget these parentheses, because this negative symbol has to be represented to the 4 and to the x before I can combine my like terms. So when I do that, okay, I have 3x minus 7 minus 4 plus x. Again, a negative with a positive is a negative with a negative is a positive. So now I'm able to combine. I have a term that has an x, I have a single term that has an x, I have a constant, and I have another constant. So when I add these constants together, okay, the 3x plus x gives me 4x. The minus 7 with a minus 4 gives me a -11. Okay, and these are my answers. Okay, the addition of f plus g is 2x minus 3. The subtraction of f minus g is 4x minus 11. Okay, any questions so far? All right, so let's do a little bit more complicated. Let's do the multiplication. So when hopefully we all know that when we have two terms together, just like here, how when we look at 2x, we know that even though there's not an operation symbol here, we know that the 2 is being multiplied to the x. So same thing with the variables. Even though we don't have a symbol here saying that these two are multiplied, because these two elements are next to each other, we know that this is representing multiplication, that we want to multiply function f with function g. And just like before, okay, if I'm multiplying function f with function g, it's just this. I'm multiplying these two functions together. So let me replace what these represent. Function f is 3x minus 7. Function g is 4 minus x. So to simplify, we're going to do some FOIL, okay? We have to multiply this term with this inner term and with this outer term, okay? This, the second term from this first function has to be multiplied with this first term, and it has to be multiplied with this last term, okay? So to simplify, we're going to do FOIL. So let's go ahead and do this. So when I multiply 3x times 4, that's going to give me a 12x. 3x times a minus x, that's going to give me a minus 3x squared. Awesome. Thank you, Yvette, for those fingers. When I multiply a -7 times 4, that's going to give me a -28. And when I multiply a -7 with a negative x, a negative with a negative is going to be a positive, and 7 times x is 7x. So now, can I combine like terms? Well, I see here that I have a 3x squared, but nothing else has a x squared, so that's a single term. But I do have a 12x here, and I have a 7x here. I have two terms that have an x, so those two are like terms, so I'm going to be combining those. So, and then again, I have a lonely constant, -28. I don't have any other constants, so I only have these two terms that are like terms. So to simplify, we're going to have a -3x squared plus 19x minus 28. Now, the order really doesn't matter as long as you have the right values, but we always like to put it in standard form. We always, in mathematics, we always like to have order, okay? And when we represent our functions, we always our degree here is a degree 2. We like to put it in descending order, okay? But the most important is that we get the like terms combined correctly, okay? Any questions on multiplying functions together? Awesome. Okay, let's do the last one. You might think that is hard, but it's the easiest one. Even though we're going to end up with a fraction, okay, division of functions are the easiest, okay? I hope you all see this, okay? So again, this means that I'm dividing function f with function g, and I just like to separate it. What this really means is I'm dividing all the values of function f, or the representation of function f, with function g. So let's go ahead and do the substitution. So f of x is represented by 3x minus 7. G of x is being represented by 4 minus x. So there's nothing that I can simplify. This 4 minus x is an element together. So this 4 minus x cannot be simplified or subtracted or reduced from our numerator, 3x minus 7. So guess what? This is my answer. My answer for the division of function f by g is 3x minus 7 over 4 minus x, okay? But I want to throw this in because, again, your homework is going to ask you this. When you're doing these composite functions, these basic operation functions, it's always going to tell you what is the domain of this division. And the reason why is, as you all know, when we have a fraction, we never want our denominator to ever become 0, because if our denominator is ever 0, we have an undefined, right? And we'll get an error on a calculator whenever we try to divide by 0. So that's the reason why the computer homework is going to ask you, what is the domain of the function? Do you have a restriction? So let's look at this. This is a fraction, okay? And we have a denominator, which is 4 minus 6. So when we say to ourselves, if we can't see it, we're gonna say, will 4 minus x, will this ever become 0? This is our question. And if we say yes, if there's a value that we can give to x that's going to make our denominator 0, then that's going to be our restriction. That means that we cannot use that value, okay? And I'm going to show you how to represent that also in interval notation. So if we see here, there is a value that will make this denominator equal to 0. And if we don't see it, we can use algebra, right? We can subtract a negative 4 on both sides, multiply by a negative on both sides, and we see that we will get 0 whenever x is equal to 4. If I would put a 4 value here for x, 4 minus 4 is going to give me 0, which is going to give me an error. So there is a restriction on our domain. So the way we're going to write that, okay, is the domain in English is all real numbers except the value 4. We cannot use 4 in our expression, okay? So if I were to use interval notation for this, let me see if I wrote it. Yes, I did write it, okay? So if I were to write this in interval notation, again, the infinity symbol, okay? The infinity symbol is not a value. It's a number that goes on forever. So keep in mind that I'm always going to use a parentheses for a symbol for numbers that don't exist, okay? But can I use 4? No. So I'm going to use a parentheses again, because my interval for this domain for this function is all the values except for the value 4. So let's look at the left of 4. So left of 4, the value 4 is, again, we're reading from left to right, from negative infinity all the way up to 4, not including 4. And then we have this U-looking symbol. This means and, okay? But this represents that I have two parts, okay? The right side of the 4. So again, I start at 4, cannot include the 4, so hence that's why it's the parentheses. And I can use any value all the way up to infinity. I can use 6, 7, 8, 100, a million, okay, up to infinity. Again, but because the infinity is not a particular symbol, okay, I'm going to use a parentheses. Any questions? Awesome, guys. Okay, so Ms. Chuka is going to continue with the presentation, okay?
Hello, everyone. So let's go on to the next example. So it's similar to the last one we were working out, but this time our functions are x squared and 2x minus 5. And so let's look at letter A. So anytime that you see this, it's always nice to write it as it's defined. So we can say f of x plus g of x. And so the first step is to just replace what those functions are. So f of x is x squared, g of x is 2x minus 5. Then we want to simplify. In other words, is there any like terms that we can gather together? And in this case, we don't have any like terms, so our answer would be f plus g of x is equal to x squared plus 2x minus 5. Okay, so then letter B is subtraction. So again, for me, it's easier to rewrite this as f of x minus g of x. We substitute our values. And notice that we put parentheses around the g of x. And the reason we do that is so that we know that this subtraction sign is going to be distributed into all of g of x. So if we distribute negative times 2 of x and negative times negative, then we're going to get x squared minus 2x plus 5. We want to still continue to simplify. There's nothing here that we can combine, so our answer is just going to be x squared minus 2x plus 5. At any time, if you need a further explanation, just let us know in the chat, and that way we can, if you have questions, we can cover those. For the multiplication, we have f times g. This should be letter C, but I don't know why it changed it on us. But f times g is f of x times g of x. So my function f is x squared, g of x is 2x minus 5. And so if we multiply this out, we would get x squared times 2x. And so here there's a mistake here. So let me just use the pencil to correct that. So here we would get x squared times 2x is going to be 2x cubed. And x squared times negative 5 would be minus 5x squared. Okay, so this would be our answer, which I guess it's here on the next slide. And so again, we multiply our two functions together, and then we end up with this. Okay, so for letter D, division. Okay, so f divided by g of x. We have f of x divided by g of x. So f of x is x squared, and g of x is 2x minus 5. And let me just erase that. I apologize for that. I forgot to erase it. So here, there's nothing we can do to simplify this. And so this is going to be our final answer right here. Okay, so x squared divided by 2x minus 5. So the operations of the functions, these are examples of that. And as Mr. Carizales said, we always want to do the domain as well. So and they always seem to ask for the domain of the division because that's usually when we'll have restrictions. And so if you have a fraction, then you're going to have a restriction, and that's the values that make the denominator 0. So to find them, we can set the denominator equal to 0. So if I add 5, I get 2x is equal to 5. Divide by 2, and we get x is equal to 5 halves. So the domain is going to be all real numbers except for x equals 5 halves. In the web assign homework, they want you to enter it as an interval. And so the way I like to visualize this is if you had a number line. Okay, so my number line is not that pretty, but let's just assume any number line works in this point. So I'm going to just write my numbers. So 5 halves is going to be somewhere in here. So let's just put a dot here. And so what this is saying is that the domain is everything. So you can use all of these numbers until you get to that 5 halves. And to represent all of these numbers in green, we use the negative infinity. Okay, so we write negative infinity here. And then we get to the 5 halves. So there should be 5 halves here. And we use the parentheses because we do not want to include that number. Because if we include it, we get 0 in the denominator. So we take this away, but then we have other stuff on the right side. So that's where the union symbol comes in. And as Mr. Carizales says, it stands for and. So the math term is the union sign. And so then we can continue and use all of these numbers to the right, which is going to be positive infinity. So we will have here should be from 5/2. So let's switch that out. So thank you, Ruben, there for switching that out. So this should be from 5/2 to infinity. Okay, and one way you can make sure that you keep your answer straight here is that the smallest number should always be on the left side. So in this case, it's still on the left side, but it shouldn't have been negative infinity. It should have been positive infinity. So our answer is going to be negative infinity, comma 5/2, union 5/2 to infinity. Okay, so let's go to the next example. So now this one looks a little bit more interesting, right? We have a squared and then we have a square root. And so we just follow the same process. So first we can write the way it's defined, f of x plus g of x. We're going to substitute the values. F of x is x squared plus 3. So I'm going to replace that here for f of x. And then I have plus g of x. G of x is the square root of 2 minus x. And so we can try to simplify, but if you notice here, we don't have any like terms, so my answer is going to be x squared plus the square root of 2 minus x plus 3. And as Mr. Carizales said, if you left your answer like this, that would still be counted correct. Okay. So subtraction, f of x minus g of x, substitute our values. Again, I'm using parentheses in case I have other stuff attached to the square root 2 minus x. And so here I'm going to end up with x squared plus 3 minus the square root of 2 minus x. And so my final answer would be x squared plus 3 minus square root of 2 minus x. Any questions on A or B? Okay, so let's try the multiplication. So we have x squared plus 3, and then times the square root of 2 minus x. And so we can multiply this out, like we can go x squared times the square root of 2 minus x, and 3 times the square root of 2 minus x. But on WebAssign, if you leave your answer like this, it's going to accept it, okay? But again, you can simplify. I always tell students to simplify as much as you can, but this will work since you have the square root. And this should say f times g. Okay, for division, same idea. We substitute x squared plus 3 divided by the square root of 2 minus x. And so there's nothing we can do as far as simplifying. So our final answer is just going to be x squared plus 3 divided by square root of 2 minus x. Since you have a fraction, then that should automatically tell you that there's going to be some restrictions that we might have to worry about. And so to find them, if you have a fraction or if you have a square root, those will give you restrictions. And then the third situation would be when you have a logarithm, which we'll talk about in chapter 3. But for now, if you see a fraction or if you see a square root symbol, then more than likely you're going to have a restriction. So let's worry about the fraction first. So in the denominator, I have the square root of 2 minus x is equal to 0. So if to get rid of that square root, we can square both sides, and we would end up with 2 minus x is equal to 0. And if I solve for x, I can add x on both sides, and I get 2 is equal to x. So what that means is if you put a 2 in here, 2 minus 2 is 0, square root of 0 is 0, so you would have a 0 down here, and we cannot divide by 0, okay? And then for the square root, we have to worry about negative numbers. So to figure those out, we take the radicand. The radicand is what's inside of the square root, and we set it greater than or equal to 0. So here, if I add x on both sides, then we get 2 is greater than x. For some of us, it's easier to read it this way. So I just rewrote 2 greater than x to be x is less than or equal to 2. And so our domain is going to be our real numbers, except x equals 2 and anything greater than 2. Okay, so our domain is going to be, oops, let me go back, from negative infinity all the way to 2. And do I include the 2? We cannot include the 2 because then we get a 0 here. That's why I use a parentheses. Question on this one. Okay, so those were operations of functions. Now we're going to look at composition of functions. And so whenever you see this little circle, it doesn't mean to multiply, it means composition. So the way we read this is f composed of g, g composed of f, g composed of g. Okay. And so they want us to find these 3 things given that f of x is x plus 4 and g of x is x minus 3. So the first thing is I like to rewrite this the way it's defined so that it makes better sense for me. So whenever you see f composed of g, the furthest function to the left would be on the outside, and then we can rewrite this as f of g of x. Okay. So the first thing we want to do is replace the g of x with what is given to us. So g of x here is x minus 3. So we're going to replace that. And now we just have an evaluation of a function. So we want to figure out what f of x minus 3 is. And so what we're going to do to evaluate it is we take what is inside and we plug it in for the x of the function f. Okay, so if we do that, then for this x here, we replaced it with x minus 3. Okay, so we keep simplifying. So x minus 3 plus 4 is going to be negative 3 plus 4 is just 1. So the composition of f of g is going to be x plus 1. So again, the first thing is to rewrite this as f of g of x. We substitute our g of x in the parentheses. Whatever is left in the parentheses, we replace it into the function f, and then we simplify. So for b, we have g composed of f. So now the furthest function to the left is g. So that's going to be on the outside. And then we have f of x. So the first step is replace f of x with what is given, x plus 4. So I'm going to replace that. And now I'm going to evaluate g of x plus 4. So what that means is we're going to take everything in the parentheses and we're going to go to the function g, and wherever we see an x, we're going to replace with x plus 4. Okay, so here, this x plus 4 was replaced by this x, or the x was replaced by x plus 4. And if we simplify, we get x plus 1. So here, if you notice, f composed of g gave us x plus 1. G composed of f also gives us x plus 1. And so we might be thinking, is that always going to be the case? Are these two always going to be the same? And so I'll let you think about that, and then here in a second, you can answer that question. So what if they give us the same function? It's okay. We still write it as g of x. So we're going to replace what g of x is, x minus 3. And now we're going to take all of this and plug it in for my x. So I'm going to have x minus 3 minus 3. So we have x minus 6. So this is going to be our composition. So this should be a g. Okay. So let's try a different example. Same problem, find the 3 different compositions. So f of g of x, let's replace g of x in here. So we have f of x minus 2. And so if we take this and plug it in for the x here, then we get x minus 2 squared. And if I simplify, that just means that I'm going to multiply this twice. And so we would distribute here, or FOIL, x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, negative 2 times negative 2 is positive 4. Gather our like terms, negative 2x, negative 2x is negative 4x. So our composition for f of g is going to be x squared minus 4x plus 4. If we flip it around, are we going to get the same thing like we did in the first example? So let's check it out. So f of x is x squared. If I plug in x squared for x, then I end up with x squared minus 2. And there's nothing else I can do to simplify. And so if you notice, we get two different answers. So the first question I asked, will they always be the same? The answer is no. That was just a coincidence on that first example. Okay, so f of g and g of f do not always give you the same solution. Okay, so g of x and g of x, we get, substitute g of x here, we get x minus 2. Plug it in, x minus 2 minus 2. So again, don't forget that we're just evaluating the function g at x minus 2, and we're substituting in for x. So minus 2 gives us minus 4. So this would be our answer. So the next two examples are going to be similar to the ones we just did. However, they're adding letter C here, which is find the domain of each function and each composite function. So first we'll find the compositions. F of g, we can rewrite it as f of g of x. Replace g of x with x squared. And now we're going to take whatever we have in the parentheses and substitute it in for the x in the function f. So if I plug this in, x squared into the x, then I'm left with square root of x squared plus 4. And so that's going to be my composition. Let's look at B. So I can rewrite it as g of f of x, replace the f of x with square root of x plus 4. And so now what we're doing is we're taking what's in the parentheses and finding the function g and replacing it for x. So here we get the square root of x plus 4 squared. The square and the square root will become 1. Or in other words, some students like to say they cancel. And so we end up with x equals x plus 4. So the composition is going to be x plus 4. So go ahead and take like a minute and see if you can find the domain of this function and this one. Okay, so first we'll do them individually, f of x, and then we'll do g of x. And then they want us to find the rest of the composition. So let's look at the function f. So the domain of f, so right away, since you have a square root, then that means that there's a really good chance that there's going to be a restriction, okay? So to find that, we take the radicand, which is the inside. We set it greater than or equal to 0 and solve for x. So x is greater than or equal to negative 4. And so here, for the domain of f, it's telling us that the domain is going to be from negative 4 to infinity. And notice that I use a bracket because of that equal sign here. Okay. And just in case you're doing some of the homework problems, if you ever have to divide or multiply by a negative for x when you have an inequality, then you're going to need to switch the sign. So if this was a negative x and I divide by negative 1, then I would have to switch this sign to be a less than or equal to. Okay. It's not the case here, but sometimes you run into that. So for g, we have x squared. So what I like to tell my students is to ask yourself, do you have any fractions? And the answer is no. Do you have any square roots? The answer is no, right? We don't have a square root. Do you have any logarithms? The answer is no, because it would have the word log in there. Since you said no to all three of those things, then your domain is always going to be negative infinity to positive infinity. In other words, it doesn't have any restrictions. Okay, so those are the domains of each of those. Now the tricky part comes when they ask, what is the domain of your composition? So we'll look at A first. So the domain of f of g, it's in 2 steps. First, you need to find the domain of your answer. So my answer here was the square root of x squared plus 4. Square root of x squared plus 4. So if I put this radicand greater than or equal to 0, I'm going to end up with an imaginary solution. If you notice, since your x is squared, if you have a negative number in there, it's always going to become positive, which means that anything in the square root is always going to be positive. So there's not going to be any restrictions here. And so we're going to have negative infinity to positive infinity. So that's always the first step, is what is the domain of the answer you got for the composition. Then the second step is to consider the domain of the second equation, of the second function. So here I have f of g. So you want to consider the domain of just the second function. And I put it here in blue, consider the domain of g. We already found it, it's negative infinity to positive infinity. So your domain, or your domain for the whole thing, is going to be a combination, not a combination, what they have in common. So what does this have in common with this? And basically they have everything in common, right? So it's going to be negative infinity to positive infinity. Okay, so again, it's going to be done in 2 steps. So again, let's look at this example. So the first step is look at the actual answer, which was x plus 4. And x plus 4 doesn't have fractions, it doesn't have square roots, and it doesn't have logarithms. So your domain is negative infinity to positive infinity. Then we're going to look at the domain of f. So why f? The reason it's f is because it's the second function here. Okay. So the domain of f, we said, was from negative 4 to infinity. Okay. So our domain, what is give me a second. What does the 2 have in common from negative 4 to positive infinity? Any questions on that?
I forgot my charger.
Okay, get it. Okay, so let's go on to the next one. So Ruben, can you take over on this one, please?
Yes, ma'am. Okay, so let's do this one. So we're going to do the composite functions of f dot g. Okay, so f composed of g. So let's do A. Okay, so we first, as Yvette stated, we're going to replace it. So f composed of this function g of x. So the first thing I'm going to replace what gx represents, which is x plus 2. So we have the function f of x plus 2. So everywhere I see x for my function f of x, I'm going to replace it with x plus 2. So it's going to give me 1 over x plus 2. Again, we want to simplify our answers, and there's nothing that I can simplify, so my answer is going to be just 1 over x plus 2. Okay, so let's go ahead and do B. G dot f, so this means g composed of the function f of x. So let's go ahead and replace f of x with its representation. So we have g, and our input value is 1 over x. So everywhere we see x for our function g, we're going to replace it with 1 over x. So we have 1 over x plus 2. Okay, so we could combine these, but again, the computer, if you give this answer, it's going to mark it right for you. Okay. So our composite function for f dot g, again, the answer is 1 over x plus 2. The answer for g composed of f is 1 over x plus 2. So again, let's go ahead and verify the domains for the individual functions itself. Again, when we have the function f of x, we see that, ooh, we have a fraction. So because we have a fraction, it's a little red flag. There's possibly a restriction on this. So, and this one's fairly easy. The bottom is x. So we know that x can never be 0. So for our function f of x, we cannot put 0. So 0 will give us a restriction or an error if we're plugging in the calculator. So an interval notation, again, from left to right, from negative infinity to 0, union 0 to positive infinity. Okay? Let's look at the function g. As Ms. Chuka stated, is function g, does it have a fraction? The answer is no. Is there a radical? Is there a square root? The answer is no. Do you see the words log in there? No, there's not a log function. So since these are not any of those three, this has no restrictions. So our answer is going to be all real numbers from negative infinity to positive infinity. So let's go ahead and look at the composites now. Okay, so if we look at the composite of f composed of g, we first have to look at the answer. If we look at the answer that we have, it was 1 over x plus 2, and that gave us this restriction. If we, is x plus 2 ever going to become 0? So again, we do x plus 2 is equal to 0, and we find out that if x is equal to negative 2, we're going to get a restriction. So for our answer, in interval notation, is going to be from negative infinity to negative 2. I cannot use the negative 2, so again, it's a parentheses, and, or union, from negative 2 to positive infinity. Now, let's look at what is the domain for the g, okay? So for the g was x plus 2. This is all real numbers. We didn't have any restrictions, but again, what do these two answers share? Well, what they share is these values from negative infinity to negative 2 and negative 2 to infinity, okay? Any questions? All right, so just think we'll finish this one up too. Let's look at the domain of our answer of our composite g composed of f. Okay, we have a fraction here, so we cannot have x equal to 0, so our domain for our answer is negative infinity to 0 and from 0 to infinity, again, not including 0. Now let's consider what the domain is of f. Again, the furthest in, the domain for f is negative infinity to 0 union 0 to infinity, so they share both the same answer. So the answer for the composite is negative infinity to 0 union 0 to infinity, okay? And we like to give these examples because, again, these are homework problems that they have on the computer, and it's very easy just to look at the answer and say it's based on the answer. But when you're looking at the composites, you have to look at these two steps. You have to look at the answer, and you have to look at the inner function, and the answer is based on what is shared on both. Okay, very, very, very important. Any questions?
So I think we only have 2 minutes left. So let me just do this last example really quick. So here, the h of x, they give you the answer. This is kind of like the answer. Let me go back here. This is the answer this answer here is what they're giving you in this example. And they want you to find the f and the g. So one way to do that is to think of it this way. You're going to have an f of x. You're going to have a g of x. So the first one you can say is whatever's in the parentheses. And the second one is going to be what's outside of the parentheses. And so for f of x, the inside of the parentheses here is 3x plus 9. So that would be my function. And what I mean by the outside is you have a square here. So you're putting this, all this stuff is going to go into somewhere. And that somewhere we can call it x. And so we will get x squared. If you're not sure if you pick the right things for your functions, then if you set them up as a composition, then you're going to see that it gives you the same answer that they started with. Okay. So this one is also really quick. Here again, they want you to figure out what f and g are. And so here, whatever's in the square root, that's going to be one function, and the actual radical is going to be another function. So f of x would be 2 minus x, and g of x would just be the square root of, think about where are you going to place this 2 minus x. It has to go in somewhere. So we can just call it x. So on the computer, you can enter your answer as 2 minus x, comma, square root of x. And there's different solutions, like Ruben could have called f of x the square root of x and g of x 2 minus x. So it doesn't matter. There's multiple solutions for this two types of problem. And I believe that is all that we have for you. So if you're watching, let me just add this last statement here. For those of you that might are watching later at home or something, just go ahead and enter the answers for, let me go to the slide, for A and B of slide 128. And so I guess that is it for today. Thank you all for coming. We do have some awesome tutors here in the presentation today. And so I want to encourage you, if you have any questions on your homework, feel free to just stay here, put in the chat that you would like to get some tutoring. And what happens is you'll get one-on-one tutoring. They'll take you to another room within the same, you don't have to log off or anything. And so if you just need them to help you with a particular homework question, or maybe something in the presentation was not clear, they're going to be here for some time. So take advantage of that. And they did put a survey. So if you are 1 credit from your instructor, some teachers are giving extra credit for attending. Make sure that you sign in. So if you don't sign in, then there's no way for you to get the credit, because your teacher won't know that you came. So thank you, everybody.
Thank you, Ms. Chuka. Thank you, Mr. Carizales. I'll be stopping the recording now.